So this is deep learning. Specifically, this is what are called convolutional neural networks that you're seeing running here. The way that you train a convolutional neural network, imagine showing millions of flashcards to your kids saying, what's this, what's this, what's this?
Okay.
And they slowly learn over time, how to distinguish between objects. So you can do the same thing with detection. You can learn basically giving examples of drawing boxes around objects,
okay.
and you can make the computer learn that.
Okay.
Or you can make the computer segment. So you can think about coloring in all the services you can drive on, color the people.
Okay.
So you can teach a computer to do that as well. So the advantage of that is it's now a data crunching problem. There's no people writing lots of code, no if then else statements, no switch blocks, none of that. You're basically just pumping data through, and it basically trains a network on its own. They're also probabilistic as opposed to rigid.
Okay.
Like if then else things, meaning that they deal better under difficult situations.
Okay.
They fail more politely.
Okay.
So you can think about lane following. So what do you do as a human? What do you do if you can't see the lane?
Yeah.
Well, you kind of keep going, or you try to just guess where the middle is.
Okay.
Right.
Okay.
So neural networks are better at sort of reasoning under uncertainty.
Okay.
And doing that type of work. So we can combine neural networks with lots of other sensors. So lidars, mainly what we're showing, and radar and everything else. So we can do a full three-dimensional reconstruction around us,
okay.
which then allows us to do more complex path planning, so that we can maneuver the car through the scene,
okay.
Emergency stop, keeping distance, all those types of things.
Okay. Can you show me some examples of what the stuff you're talking about?
Sure. So this is an example that you can see here. So this is actually a challenge video we were given to by Audi.
Yep.
So it's a difficult scenario for most optical systems because you're doing in the snow, you have very low contrast,
okay.
But we're still able to actually take a network we trained on an open data set and apply it to a customer data set very rapidly,
okay.
And do very solid detections on it.
Okay.
So besides single class detection, we can also do multi-class detection. We'll comment on a little bit. So simultaneously, at the same level of performance, we can detect cars and people and bicycles and street lights and everything else.
Okay.
So if we move down here, so we can combine multiple sensors together.
Mm-hmm.
So this is 6 cameras,
okay.
4 lidars, all being processed simultaneously.
Mm-hmm.
So we fuse those things together to allow us to reconstruct the environment.
Okay.
So this is the lidar all being reconstructed together. So the 4 lidars all being processed, realigned.
Okay.
It's a fair amount of compute to do that. And then we can project that into the 3D world as we're driving. So you can see where the various cars and objects are.
Okay.
So there's our car in 2D, so we can see the obstacles around us. The white that you see is from the LiDAR and the optical reconstruction, and then the green is from the neural network identifying where the object is in the scene.
Okay.
So here's an example of the neural network doing detection and classification of the objects.
Okay.
So what's a car, what's a truck, things like that. So once we have that,
all these software features are designed.
Take a high resolution map. So this is a map from the guys from here. And so we can very precisely locate ourselves. Standard GPS is only good to about 2 meters, but we can now locate ourselves to within about 20 centimeters in the real world. And then so from that, it allows us to do a full reconstruction and plan through the scene.
Okay.
So the yellow lines being a potential pass for us to cross. As this car closes up, we're going to violate the capabilities of the vehicle dynamics.
Wow.
So we'll say that you're no longer capable of doing that pass maneuver.
Oh, wow.
So it's a full dynamic reconstruction. And because it's too complex to show to a driver in this form, we simplify it down into a cluster, which is there all the way at the end. So you can see the video up top and the real live code running. And so then we have a proof of concept of how it works, all integrated all together.
Okay. Okay. Cool. Very awesome.
Sure.
Okay. Thank you.
No problem.